For question number 77, we're going to take a look at the gas law because we have a pressure, a temperature, a volume. The only thing we have to be concerned about is the Celsius temperature that needs to be converted to Kelvin. So the setup will look something like this. Okay, so you have P1 V1 over T1 equals P2 V2 over T2. Since we are talking about the gas laws, we're talking about STP. We have actual values for STP. It's 273 Kelvin. And this time we're going to use 101.3 kPa because it's asking for the answers in kilopascals. So we can use either pressure value from table A. So here are our givens. You have 101 kPa, 101.3 kPa, and you have your volume at 50. Temperature is 273 Kelvin. You're looking for P2. Your V2 is 20 liters, and T2 is 337 Kelvin. You're going to take all those values and put them into the equation where they belong. And you see that P2 is what we're going to be solving for. So we want to get P2 to be alone. We're going to take the 337, bring it up here in this area right next to the 50 liters. And then we're going to take the 20 liters and cross it down, multiplying it to the 273. And this is what it's going to look like once you set it up. These are all the numbers setting up to solve for P2. Once you solve, you get 312.6 kPa. Now for question number 78 and 79. They both are dealing with this graph. They also have some information given to you in the beginning. It's talking about a 15-gram sample that starts below its melting point, and heat is being added, so we're absorbing some energy at the rate of 20 kilojoules per minute. So the first question says, calculate the heat of fusion of the substance. So we know it's not going to be water, it's not H2O, therefore we don't have HF. We need to solve for HF. So starting with our problem here. Okay, heat of fusion. So it first says heat is being added. So that's going to give us our joules that we're trying to get. So let's take a look at that a little bit more closely. It says heat is being added at 20 kilojoules per minute. And if you look at line B on the problem there on the graph, line B takes 4 minutes for the substance to melt. So to completely melt line B, it takes 80 kilojoules. So Q is 80 kilojoules from time 4 to time 8 on line B on the graph. The mass is given to you from the problem up above, and that's 15 grams. Now I have the information I need to find my HF for this substance. I have 80 kilojoules equals 15 grams times HF. Solving for HF, you're going to divide both sides by 15. So it's 5.3 kilojoules per gram. And you can leave the answer in kilojoules. If you want to convert it, you would just multiply by 1,000, and that would give you joules per gram. And then for question number 79, there's two parts to that. There's A and B. 79A asks about the heat of vaporization versus the heat of fusion. If you take a look at the graph for B, heat of vaporization is here for, at D. And that takes from 12 to 18 minutes to happen. So that takes 6 minutes versus B, which takes 4 minutes. So if you have 4 minutes versus 6 minutes, and you multiply 20 kilojoules per minute, well, D is going to need more energy than B would because it takes longer. So HV is greater than HF for part A. And then for B, it's pretty much what we just said, using the graph as the explanation. If at B, it's 4 minutes, because it goes from 4 minutes to 8 minutes, takes 4 minutes to melt. Therefore, it would be 4 times 20, which would be 80 for B. Whereas D, it's from 12 minutes to 18 minutes, which is 6 minutes total for it to vaporize. So 6 times 20 is 120 kilojoules. Therefore, it takes more energy for D than it does for B.